So I'm doing my final project on the firefighting math, more specifically the spread of how fast fire can spread. I was going to do it on the paramedic field, but they both overlap each other, and so I was just going to do it on fire anyway. So the basic math in calculating the speed of fire isn't very complicated. You just take the time fire has been around and divide it by the distance it's traveled so far. As you can see up here, you can see the calculations right there, time divided by the distance. And for an example, a forest fire has started in the mountains of Utah. The fire has traveled for 2 miles and 30 minutes. How fast is the fire traveling? You take the time and divide it by the distance. In this case, it would be 30 divided by 2, which equals 15 minutes per every 1 mile. And to make that into miles per hour, we can just we can get 60 and divide it by the 15 minutes. 60 divided by the fire spread, which would give us a time of 4 miles per hour. And for a simpler way of calculating the speed of fire, if you know the wind speed, then you can just take the wind speed and then multiply it by 0.5 to get 10% of the wind speed. This is usually the rate of how fast the fire is going. This method is a lot simpler, but it's more of a rough estimation as it only accounts for the wind and no other factors. A few of the other factors are the low flash point of fuel, which includes grass, paper, oils, and most woods. So what low flash point means is that it burns really quickly and really easily, but it doesn't last very long. So it just burns through all of its fuel really quickly, and then there's nothing left. Higher flash point fuels such as cedar, bark, or pine, or some cooking oils, they burn a lot. It takes a lot more energy for them to start burning, but when they do start burning, they burn for a lot longer, and so yeah, it just takes a lot longer for it to burn. And there's also other materials like steel, stone, grass, and concrete, which all can't burn at all. So it can kind of hinder a fire and stop it. Other factors include the fuel size involved. The bigger the fuel, then the harder it is for it to catch fire, but the longer it'll burn. The smaller the fuel, the more area it can burn up quickly. So it'll burn through it quickly, but it won't leave any more fuel. Sort of like the high flash point and low flash point. And the last factor is the moisture content. If you have ever stuck like a living branch into a fire, it smokes quite a bit before burning. That's because the fire has to evaporate all the moisture inside of it to actually use it as fuel. And that's my presentation.